Hello dear students, welcome to another lecture of engineering mechanics. This is lecture number 17 and in this lecture we are going to deal with kinematics of two-dimensional translational motion. Yesterday we have completed kinematics of one-dimensional translational motion. Today we are going to continue that discussion and we will move on to the two-dimensional translational motion, also known as curvilinear translational motion. But before starting the lecture, as always, let's first discuss the assignment problem. So this was the question I gave you in the last class as an assignment. The equation of motion of a particle moving along a straight line is given by A equal to 3t square minus t plus 4, where A is the acceleration and t is the time. Velocity of the particle at t equals to 2 seconds is 25 meter per second. Velocity at t equals to 4 seconds is. So here we have the equation of acceleration and we need to find the velocity. So how are we going to do it? We know the relation between acceleration and velocity, right? A equals to dv by dt. Wait a minute. And it is equal to what? 3t square minus t plus 4. So I can write dv is equal to 3t square minus t plus 4 dt. Now if I integrate this equation, I can find the velocity. But what will be the limit of integration? See, the lower limit of time is 2 seconds and at t equals to 2 seconds, velocity is 25 meter per second. So this will be 2, this will be 25. We need to find the velocity at t equals to 4 seconds. So this will be 4 and this will be the unknown v. So if I integrate the left hand side, I will get v minus 25. And if I integrate the right hand side, I will get 3t cube by 3 minus t square by 2 plus 4t, and the limit will be 2 to 4. After solving this, we will get the required velocity. So we are getting 83 meter per second. So this will be the velocity at t equals to 4 seconds. At t equals to 2 seconds, the velocity was how much? 25 meter per second, and at t equals to 4 seconds, it will become 83 meter per second. So this is the solution of the last class assignment problem. Now let's move on to today's lecture. So what we are going to cover in this lecture, we are going to talk about curvilinear translational motion. And a very important type of curvilinear translational motion is projectile motion. Okay, so although I have written it as a separate topic, but it is part of curvilinear translational motion. It is not a different motion, it is a type of curvilinear translational motion. Okay, so let's talk about curvilinear translational motion. So we know that translational motions are of two types, rectilinear and curvilinear. Rectilinear means the path of motion will be a straight line either in x or in y. Okay, but curvilinear means the path of motion is curved. So you can say that this is a one-dimensional translational motion and this is a two-dimensional translational motion. Here the velocity, the acceleration, the displacement has only one component, either x or y component. But here displacement, velocity, accelerations will have x as well as y component. So this is a two-dimensional motion. Okay. So in case of curvilinear translational motion, all particles of the body move along curved lines. So let's say this is the path. Okay, and we have a car which is moving on this curved path. Now you can see that at different times the direction of velocity is changing, right? At this point, if you see, the velocity at any particle will be something like this. It will be tangential to the path. Okay, so let's consider this as a path. It will be tangential to the path. Here it will be something like this. Here it will be something like this. Okay. Now if I resolve this velocity, I will get a velocity in x, a velocity in y. Same here, velocity in x, velocity in y. Same here, velocity in x, velocity in y. Okay, so this is a two-dimensional translational motion. Okay, now understand this fact. If this path becomes circular and the car is moving along this circular path, then also it will be a curvilinear translational motion only. The difference is that this time the path is completely circular. So it is still a curvilinear translational motion only. Okay, circular motion. It is a curvilinear translational motion only. There is a difference between circular motion and rotational motion. Okay, Earth is rotating about its own axis, but it is in circular motion around the sun. So there is a difference between the two things. Okay, so rotational motion is completely different thing, circular motion is completely different thing. Okay, chalo. Now in case of rectilinear translational motion, we have defined our motion variables. Now in curvilinear translational motion also we need to define our motion variables, because whatever equation we are going to use, they will be in terms of motion variables only, right? So we need to first define the motion variables. Now the motion variables here will be slightly different than rectilinear translational motion. Why? Because in rectilinear translational motion everything was happening in one dimension, and here everything is happening in two dimension. Okay, chalo. So the first motion variables that we are going to see will be the position. Okay, so let's say this is our XY plane. And let's say that this is the path of motion. Okay, a particle is moving along this path. It is a curved path. Okay, right now the particle is here, and this is the origin. Okay, if it was a rectilinear translational motion, in order to define the position, we need only one variable, we need only one coordinate, either the x coordinate or the y coordinate. But here, in order to define the position of this particle with respect to origin, we need the x coordinate as well as the y coordinate. In other language, we need a vector, right? We need this vector. What is this vector? This vector is known as the position vector. Okay, it is defined by r, it is denoted by r. Okay, position vector is denoted by r. Okay, so how do we write the position vector? The position vector r will be equal to 𝑋𝐼 plus 𝑌𝑗̂. Okay, where I and j are what? Unit vectors in x and y direction. Okay, so r is 𝑋𝐼 plus 𝑌𝑗̂. So this is the position vector at any position. It is used to define the position of the particle along the curved path. Okay. Now let's move on to the next motion variable, which is the displacement. So how do we define displacement here? In case of rectilinear translational motion, I told you that you don't need to define the displacement as the shortest distance between the initial and final position, but here we are going to use that. So let's consider again the XY plane, and let's consider again a curved path. Let's say initially the particle was here and then the particle moved to here. Okay, this is the origin. Now understand, this is the initial position of the particle, this is the final position of the particle. Okay, the particle moved from here to here. I need to find the displacement between these two particles. Understand, this is the initial position and this is the final position, right? Let me call this one as R1 and this one as R2. Okay, now if I draw a line joining this particle and this particle, if I draw a vector, then this is known as the displacement vector. Okay, from the initial position to the final position, this is the displacement vector. Okay, this is the initial position, position number 1, final position, position number 2. So this is the displacement vector. Now can you see that the actual path from 1 to 2 is this? The actual path from 1 to 2 is this, but we are considering this path, which is the shortest path between 1 and 2. Okay, now look at this triangle. Can you see this triangle? According to triangle law, I can write R2 equals to R1 plus S, right? R2 is equal to R1 plus S. R2 is the resultant of R1 and S. So I can write R2 is equal to R1 plus S. So the S, the displacement vector, can be written as R2 minus R1. Okay. So this is the difference of the position vectors of initial and final positions. Now let's say that R1 is x1 I cap plus y1 j cap. Let's say x1 and y1 are the initial position coordinates of position 1, and R2 is equal to x2 I cap plus y2 j cap. So now what you can do is S will be equal to x2 minus x1 I cap plus y2 minus y1 j cap. Or you can write it like this: x2 minus x1 can be written as sx and y2 minus y1 can be written as sy. So here sx is x2 minus x1 and sy is y2 minus y1. Now you can see that this displacement vector has two components, one x component, one y component. So beta, in curvilinear translational motion, you don't have to worry about solving the problem, because here the entire concept, the entire procedure of solving the problems is same. The only thing is here you need to calculate everything once in x, then next in y. For example, if you are calculating velocity, calculate velocity in x and velocity in y separately. If you are calculating acceleration, calculate acceleration in x and acceleration in y separately. That's it. Okay. Let's move on to the next motion variable, which is the velocity. Velocity is defined as the rate of change in its position, and we have already defined the velocity, instantaneous velocity. V is equal to ds by dt, right? Now here the displacement vector is sxi cap plus syj cap, right? So here you can write it like this: dsx by dt I cap plus dsy by dt j cap. Now if you differentiate the displacement in x with respect to time, you will get the velocity in x, and if you differentiate the displacement in y with respect to time, you will get the velocity in y. So I can write this as Vx I cap plus Vy j cap. Okay. If someone asks you what is the magnitude of velocity, then you need to do this. That's it. And you can also find the direction of this velocity with respect to x. Tan inverse of Vy by Vx. Okay. So very simple. If you have the displacement in x, differentiate it with respect to time, you will get velocity in x. If you have the displacement in y, differentiate it with respect to time, you will get the velocity in y. Simple. Okay. Once you get the velocity in x and y, take the resultant and you will get the total velocity. In the same way, we can find out the acceleration also. A is equal to dv by dt, right? So it will be d by dt of Vx I cap plus Vy j cap. So it will become dvx by dt I cap dvy by dt j cap. Now what is dvx by dt? It is acceleration in x, and dvy by dt, it is acceleration in y. So you have got the acceleration, and if they ask you the magnitude of acceleration, do the same thing. Take the resultant of ax and ay. Okay. Very simple. Okay. So I hope it is clear to you how to find the motion variables in case of curvilinear translational motion. Let's solve a few problems in order to have a better idea. So this is the first problem. A particle has initial velocity of 3 cap plus 5 j cap and an acceleration of 2 cap plus j cap. You can see that here acceleration is constant, right? This is the value of acceleration. Okay, it is not mentioned that this is the acceleration at a particular time. They are saying that the particle is moving with this acceleration and there is no time variable here. So this acceleration is independent of time, it is constant. So here we can apply the equations of motions under uniform acceleration. Remember, last class we found 3 equations of motion under uniform acceleration. V equals to u plus at, s equals to ut plus half at square, v square minus u square equals to 2as. We can use that equation here. Okay. So here what they have given you, they have given you the initial velocity. Now initial velocity in x is 3 meter per second. Initial velocity in y is 5 meter per second, right? This is the x component, this is the y component. Now acceleration in x is 2 meter per second and acceleration in y is 1 meter per second, and at t equals to 5 they want us to calculate the final velocity. So what we are going to do is we are going to find the velocity in x and velocity in y separately. Okay, so Vx will be equal to ux plus ax into t. So ux is how much? Ux is 3 meter per second, ax is 2 meter per second square, sorry, this is square, and time is 5 seconds. So Vx is equal to 13 meter per second. Okay, so this is the velocity in x. Similarly, Vy equal to uy plus ay into t. So Vy will be equal to uy, which is 5 meter per second, plus ay into t, which is 1 meter per second square into 5. So this will be 10 meter per second. So we have the velocity in x, we have the velocity in y, but they are asking you the velocity, total velocity. So it will be equal to root over Vx square plus Vy square, root over 13 square plus 10 square. So I am getting 16.40 meter per second. So this is the final velocity after 5 seconds, 16.4 meter per second. Let's move on to the next question. A particle is traveling along the straight path y equals to 0.5x. Now you must be wondering, sir, this is a straight path, then how come it is curvilinear translational motion? I told you, straight path means it should be either in x or in y in order to be rectilinear translation. If it is like this, then also we will consider it as curvilinear translation. Okay, two-dimensional translation, na? Okay, so here the straight path is y equals to 0.5x. It is something like this. Okay, so this will also be solved using the concepts of curvilinear translation only, two-dimensional translation. If its position along the x-axis is x equals to 2t, where t is in seconds, speed of the particle at t equals to 4 seconds is. So they have given you the equation of motion in x direction, x equals to 2t. Okay, and they are asking you to find the total velocity. Now if you have the displacement, how do you find the velocity? By differentiation. But here we need to find the velocity in x and velocity in y separately. Okay, so here we have the equation of x, x equals to 2t. How will you find the equation of y? Understand, y is 0.5x, na? So if I put the value of x in terms of t, I will also get y. So x is equal to 2t and y is equal to t. Now we can find the speed. So Vx will be equal to dx by dt. So it will be d by dt of 2t. So Vx is equal to 2 meter per second, right? Now understand this. Here we are not getting t, means velocity will remain constant with respect to time. So this is, they have mentioned at t equals to 4 we need to find the velocity, but doesn't matter, at every speed, at every time the speed will remain same, 2 meter per second. Similarly, Vy is equal to dy by dt. So it will be d by dt of t, which will be 1 meter per second. Okay. So here we have Vx, we have Vy. So V will be equal to root over Vx square plus Vy square. Both velocities are constant. Okay. The particle is moving with constant acceleration. So V will be equal to root over 5 means 2.236 meter per second. Okay. Chalo. Moving on to the next question. Now this is an interesting one. The box slides down the slope described by the equation y equal to 0.1 x square, where x is in meters. The box has x components of velocity and acceleration. Vx equals to minus 3 meter per second, ax equals to minus 1.5 meter per second square at x equals to 5 meters. Determine the y components of the velocity and the acceleration at this instant. So the path of motion is given y equals to 0.1 x square. It's a curved path, parabolic path, y equals to 0.1 x square. And then we have the x and y, x component of velocity and acceleration at a particular value of x. We need to find the y component of velocity and acceleration at the same value of x. Okay. Now understand how to solve this problem. First of all, y is 0.1 x square. Understand this. We have Vx, we have Ax. Okay. What is Vx? Vx is actually dx by dt, and dx by dt is minus 3 meter per second. Ax is dvx by dt, which will be d square x by dt square, right? And this is minus 1.5 meter per second square at x equals to 5 meter. Okay. At x equals to 5 meter. Now understand how to solve the problem. We know the relation between y and x. Y equals to 0.1 x square, right? And we need to find Vy. What will be Vy? Vy will be dy by dt. Vx was dx by dt. Vy will be dy by dt. So if I differentiate this with respect to time, what I am going to get? Vy will become 0.1 into x square. If you differentiate with respect to time, you will get 2x dx by dt. Okay. So it is actually 0.2x dx by dt. Vy is 0.2x dx by dt. I should not write it like this. Okay. Now we need to find Vy at x equals to 5, right? So at x equals to 5, Vy will be 0.2 into what is x? x is 5 meter. And what is dx by dt at x equals to 5? Dx by dt as x equals to 5 is minus 3. So we will get the value of Vy. So it will be minus 3 meter per second. So we have got the velocity in y at x equals to 5, minus 3 meter per second. Now we need to find the acceleration in y. What will be acceleration in y? Ay will be dvy by dt, right? Now we already know the equation of Vy. Now what some people do is they put the value of Vy here. Beta, Vy is not constant, right? It depends upon time. So you need to put the equation of Vy, which is this. Don't put the value of Vy at a particular time. Understand? This is Vy at a particular instant, and this is the equation of Vy. So if you want to find the equation of Ay, you put the equation of Vy here. Don't put the value of Vy. Otherwise you will get 0. Okay, Vy is not constant with respect to time, na? Vy is changing with respect to time, like this. So here what I will do is, I will put the equation of Vy, which is 0.2 x dx by dt. So if I differentiate this, what I will get? 0.2 is constant, right? If I differentiate x dx by dt by chain rule, what is chain rule? Differentiation of u into v is equal to u into differentiation of v plus v into differentiation of u. So it will become x into differentiation of this d square x by dt square plus dx by dt into differentiation of this, which will again be dx by dt. Okay. Now put the value of x and dx by dt. At x equals to 5, Ay will be 0.2 into, what is the value of x? 5. What is d square x by dt square? Minus 1.5. Then dx by dt is minus 3. So from here I will get the value of Ay. Which is 0.3 meter per second square. So these are the y components of velocity and acceleration. Velocity in y is minus 3 meter per second and acceleration in y is 0.3 meter per second square. I hope it is clear. So we can have these type of questions in exam under curvilinear translational motion. But there is a special case of curvilinear translational motion which is known as projectile motion. You might have studied this in school, but let's again study this from the basics. I will assume that you guys don't know anything about projectile motion. Okay, chalo. So first of all, what is a projectile motion? What do we mean by a projectile motion? So projectile motion is a special case of curvilinear motion. It happens when you throw a body, or release a body in a parabolic path. The body is moving in a parabolic path under the influence of gravity near the surface of the earth. Okay, the body should move in a parabolic path. It should be under the influence of gravity only, and it should be near the surface of earth. For example, if I kick a football at some angle, then that football is moving in a parabolic path. When the football is in the air, it is under the influence of gravity only. there should be no other force acting on the body. It should be under the influence of gravity only, and it should be near the surface of the earth. Okay. If you consider the motion of a missile, then it is not projectile motion. Why? Because when the missile is in the air, it is not only acted on by gravitational force, it is not only acted on by weight. Thrust is also acting, right? Burning of the fuel is producing a thrust, so that is also acting on the missile. Okay, so the motion of missile is not example of projectile motion. Motion of bullet is also example of projectile motion. When you fire a bullet, that bullet is moving like this, it moves like this. Okay, if you consider a very short distance, then it is almost straight. Otherwise, if you hit a bullet over a very long range, then it moves like this. You can see that it is under the influence of gravity only, na? Once you hit the bullet, it moves under the influence of gravity only. There is only weight of the bullet acting on the bullet. No other force is acting. Here we are neglecting the air drag. Here we are neglecting the air friction. Okay, buoyancy of air, all these things we are neglecting. Okay, we are assuming that the body is in such a shape and it is moving at such a velocity, then all these drag forces, buoyancy forces, friction forces due to the air is negligible. Okay, so don't say that this is also present. Okay, chalo. So beta, the motion of football, the motion of cricket ball, when you hit a six, then the cricket ball is also moving in a projectile motion. Okay, then motion of bullet, they are all part of projectile motion. Okay, now when it comes to projectile motion, there are three important parameters to calculate. What are these parameters? Time of flight, maximum height, and range. Time of flight, which is denoted by capital T, is actually the total time taken by the projectile from initial position to the final position. Maximum height is the maximum displacement in y direction. Okay, means if the projectile motion is like this, then this is the maximum height, and range means the maximum displacement, the maximum distance covered in x direction. Okay, so typical projectile motion looks like this. Although there are different types of projectile motions, different types means it can start from anywhere and it can end anywhere, but a typical projectile motion looks like this. Typically we assume that the motion starts from the ground, ends on the ground. For example, let's say this is a small particle, right now it is at the origin. Okay, let's assume that a very small football, and now if you kick this football at some angle, what you have done is you have given this football an initial velocity. Okay, at some angle, let me call this angle alpha. So you have kicked this football at some angle, means you have given this football some initial velocity at an angle alpha, and now this football moves like this. Can you see? So this is the initial position and this is the final position. This is a typical projectile motion. Okay, now you can see that this is the initial velocity. It has two components, one in x, one in y. The x component will be u cos alpha, the y component will be u sin alpha. Now if you want to understand the projectile motion, what you can do is you can split this motion into two parts, motion in x motion in y. Okay, you can split this entire motion into two parts, motion in x and motion in y. So in x direction we have the initial velocity u cos alpha, in y direction you have u sin alpha. Now understand the most important thing. When this football is in the air, let's say the football is here or here or here or here, you can see that there is no force acting on the football in x direction, right? There is no force acting on the football in x direction. In x direction there is no force. And if there is no force acting on the football in x direction, it means there is no acceleration in x direction. Acceleration in x will be 0. See, according to Newton's second law, F equals to ma. So if there is force, then there will be acceleration. And in x direction, there is no force acting. Initially, when we kicked the football, we gave it some force. We applied some force. But I am talking about when the football is in the air, then there is no force in x direction on the football. But when the football is in the air, there is a force acting on the football in y direction. What is that force? That force is the weight of the football, gravitational force, which is acting downward, right? So we have acceleration in y, which is g, and it is always downward, okay? It is always downward. Now don't say that it should be plus g or minus g. I told you that whether it is plus g or minus g, it depends upon the direction of other parameters also, okay? Okay? Now, understand this. In x direction, the acceleration is 0. It means if I want to calculate the velocity in x direction, I will use this ux plus ax into t, and this ax is 0. So vx will be equal to ux. It means that the velocity in x direction will remain constant. At every point, the velocity in x will remain constant, okay? But velocity in y will be this, vy equals to uy plus ay into t, means vy equals to uy plus minus g into t. Why I have written plus minus? It depends upon the direction of ui and vy, whether this will be plus or whether this will be minus, okay? Now understand what happens is initially the initial velocity in y is upward and acceleration is downward, right? So this will be minus gt. Uy is upward and ay is downward. So this will be minus gt. Means initially the velocity will start decreasing. You can imagine this in your head. If you kick a football and when it is going up, the velocity is decreasing. And now at this point, the velocity becomes in y becomes 0. At the maximum height, the velocity in y becomes 0. And then it starts falling down. Okay. So now the velocity will start increasing. So in x direction, the velocity remains constant. In y direction, from here to here, velocity decreases, and then from here to here, velocity increases. This entire path is symmetric about the center. Okay. Entire path is symmetric about the center. Okay. So I hope you have understood this. If you want to find the velocity or displacement or acceleration anywhere, You need to just consider this motion in x and y separately. Now let's calculate these three parameters, okay? Time of flight, maximum height and range. First of all, we will calculate the time of flight, which is capital T. So how do we find the time of flight? Understand. Let's say this is point number 1, this is the initial position, and this is point number 2, final position. Okay. You can see that from 1 to 2, the displacement in x is 0. Sorry, displacement in y is 0. है ना? 1 and 2 both are on the ground. So displacement in y is 0, right? If I consider this point and this point, there is displacement in x, but displacement in y is 0. Now don't say that, sir, initially it went up, na, then it came down. I am saying that this is the initial position, this is the final position. What is the distance between them in y direction? 0. Now put the equation of motion here. What will be the equation of motion? Uy into t plus half ay into t square, right? I should write it capital T. Okay. Now uy is what? Uy is upward. Uy is upward, na? This is uy. Which is upward. And ay is always downward. Whether it is going up or down, ay will always remain downward, okay? So if I am considering this positive, this will become negative. So this will become minus u sine theta into t. Sorry, I have to consider this negative. Minus half gt square equal to 0. Now if I solve this, it will become u sine theta equals to half g into t. So t will be equals to 2u sine theta by g. So this is the time of flight. There is another way of doing it. You can consider this point as point number 1, this point as point number 2, the center point. You can calculate the time from here to here, and then you multiply 2 in that equation and you will get capital T. Okay, you can do it like that also. From here to here, you know that initial velocity is uy and final velocity will be 0 in y direction, na? You can use this equation, v equals to u plus at. V will be 0, u will be u sine theta. So t will be equals to u sine theta by g. So this is the half of the time. And if you multiply 2, it will become 2u sine theta by g. Okay, so this is the equation of the total time taken from 1 to 2. Let's move on to the next. Maximum height means we need this distance. This is the maximum height. So this is my point number 1, this is my point number 2. Now I know that at point number 2, the velocity in y will be 0, right? So I can use this equation. Vy square minus uy square equals to 2ay sy. Okay, v square minus u square equals to 2as. Now vy will be 0, uy will be upward, ay is always downward, and sy is upward. From 1 to 2, displacement is upward, na? It is going up. Now I will consider upward positive, then downward will become negative. So this will be 0 minus u sine theta whole square equal to 2 into minus g into h. So h will become u square sine square theta by 2g. So this is the maximum height, u square sine square theta by 2g. Next is the range, which is the maximum displacement in x direction. This is the range. This is point number 1, point number 2. Now from 1 to 2, how do we find this displacement? Simple, we will use the equation of displacement. Sx equals to ux into t plus half ax into t square. This will be r equal to u cos theta into, what is the time taken from 1 to 2? We have already calculated it, 2u sin theta by g. And what is ax? 0. So r will be equal to 2 sin theta cos theta is sin 2 theta. So it will be u square sin 2 theta divided by g. This is the range. Okay. So we have found the time of flight, maximum height and range. Now let me tell you this. If you remember these equations, good. But even if you don't remember them, you can always use the equations of motions to calculate the time, height and range. Okay. We have used these equations of motion in order to calculate, derive this equation. We can use the equations of motion in the questions also. Okay. Chalo. Let's solve the first question. A projectile is fired upwards from the ground at an angle 30 degree with horizontal with a velocity of 40 meter per second. Velocity of projectile after 3 seconds of firing is. So we fired the projectile from the ground at an angle of 30 degree at a velocity of 40 meter per second. This is u, this is theta. And at t equal to 3 seconds, they are asking us to find the velocity. Now understand this. Velocity in x direction will remain constant, right? Velocity in x direction will be constant, which will be u cos theta. So u is 40 and theta is 30 degree. So velocity in x will be 40 cos 30. 34.64 meter per second. So this we already know. But velocity in y, how do we find velocity in y? In order to do that, we will use this equation. We know the time, so we will use this equation. Okay. Now understand this. Here also we need to mark the arrows. Now do you know that whether after 3 seconds whether this body will be going up or down? Do you know that? No, we don't know that. So what we are going to do is we will make some assumption. Let's assume that after 3 seconds it is going up. If I get a positive answer, my assumption is correct. If I get a negative answer, my assumption is wrong. You can also assume that it is going down. If you are getting positive answer, your assumption is right. If you are getting negative answer, your assumption is wrong. So I have assumed that after 3 seconds, this projectile is going up only. Initial velocity was up only. But acceleration in y will always be downward. G is always downward. So upward values will be positive. Let's assume uy will be what? U sin theta. So it will be 40 sin 30 means 20. This will become minus g, they have mentioned 10. And this is 3 seconds. So I am getting Vy equal to 20 minus 30 minus 10 meter per second. Now what does this mean? This means that My assumption is wrong. I assumed that it is going up and it is negative, so it is actually down. Okay, so now we have the velocity in x, velocity in y. So we can find the total velocity by taking the resultant. V will be root over Vx square plus Vy square. So it will be root over 34.64 square plus minus 10 square so it is 36.05 meter per second. Okay, chalo. Moving on to the next question. A shot is fired horizontally from the top of a tower with a velocity of 100 meter per second. If the shot hits the ground after 3 seconds, distance from the foot of the tower where the shot strikes the ground is how many meters? Height of the tower is how many meters? So understand the question here. This is a tower which is on the ground, something like this. We have hit a shot and the bullet moves like this. Okay, this is position number 1, this is position number 2. Now the first thing they are asking is distance from the foot of the tower. Now the shot is fired horizontally. Okay, the shot is fired horizontally. So ux is 100 meter per second and ui is 0. Okay, so what we need to calculate, the distance from foot of the tower where the shot strikes the ground is. We need to find this. We need to find this distance. Let me call it Sx. So how do we find Sx? Very simple. Sx will be equal to ux into t plus half ax into t square. Now ux is 100 meter per second, t is 3 seconds and ax is 0. So Sx is 300 meter. So it strikes the ground after 300 meter from the foot of the tower. Second, height of the tower. So they are asking also Sy. This is the height of the tower, na? So how do we find Sy? Again, same thing. Uy into t plus half into ay into t square. Okay. Now uy is 0. Ay is, let's say, g 10. G is equal to 10, na? Okay, they have not mentioned it. I will assume g equals to 10 and t equals to 3 seconds. So it will become 5 into 9, 45 meter. So this is the height of the tower, 45 meters. Okay. So this was a very simple question, right? Now consider this one. An airplane used to drop water on bushfires is flying horizontally in a straight line at 80 meter per second at an altitude of 100 meter. Determine the distance at which the pilot should release the water so that it will hit the fire at B. So the plane is flying horizontally at 80 meter per second at a height of 100 meter. Okay, this height is 100 meter. They are saying that you need to release the water at point A so that it hits the bushes at point B. So what is this horizontal distance D? Now what we are going to do is, first we are going to calculate the time taken for the water to reach from A to B. So how we can calculate it? Very simple. We can use this equation. Sy equals to Uy into T plus half Ay into T square. Sy is given, this displacement in y is 100 meters from A to B. Uy is 0 because it is flying horizontally. Ay is g, which is 10. So from here you will get the value of time. Which is 4.47 seconds. So it takes 4.47 seconds to reach from A to B. Now I will use this equation. Sx equals to ux into t plus half ax into t square. So Sx is d, ux is, it is flying at 80 meter per second horizontally. T is 4.47 seconds from A to B. This is 0. So I am getting 357.6 meters. So you need to release the water at 357.6 meters away from the fire in order to hit the fire. Okay. Chalo. Now this is the next question, which is an assignment for you. I will discuss the solution to this question in the next class. So I hope you guys understood the concept of curvilinear translational motion as well as the special case of curvilinear translational motion, which is projectile motion. I will see you in the next class. Till then, bye bye, take care, thank you for watching.